Hello, everyone. In the next half an hour, we are going to talk about parameterized testing with GTest, where GTest stands for Google Test. But before we go into the details, let me quickly introduce myself. My name is Sandor Dargo. I work as a principal engineer for Amadeus in the south of France. So if you don't know Amadeus still, probably you used our services when you book the flight or if you book the rental car, because we are mainly working with the reservation systems. In my free time, I enjoy writing. I'm an enthusiastic blogger. I write this sandordargo.com, where I mostly post about C++, but sometimes about the books I read or some Stoic philosophy that I enjoy. Well, I used to travel a lot with my family, but for obvious reasons, it's not really the case anymore. And these days we try to experiment with sourdough baking with the kids, but that's enough about myself. So let's have a look at the agenda. First, we'll discuss how we can make our tests less repetitive without parameterized tests, because, well, as you will see, it's not a silver bullet, it's not the only solution. Then you're going to see what are parameterized tests and how we can write them by scratch, or how we can write them on the top of an existing text fixture. We'll see both. And then we'll see if we have like multiple parameters for the same test case, how to deal with that. And if we have time at the end of this half hour, we'll even see how to parameterize the types that we test. And I'll keep an eye on the questions. So if you have any questions, feel free. So why did I think that this should be a good topic to talk about? Because I think that, well, you should handle test code as you handle normal code. You should approach it with the same quality requirements, and therefore you should try to keep your test code dry. You should not repeat yourself. So if you're not familiar with this abbreviation DRY, it stands for don't repeat yourself. And parameterized testing is a great tool to achieve that. And while it's a great tool, its documentation, well, it's quite scarce. When we first started to use in my team parameterized testing a few years ago, we had some hard times in the beginning to put it together. But once you understand, you will see it's not that difficult to use it. So we are going to use some code examples based on the leap year kata, which, well, basically you pass the year as an input, an integer, and the function will tell you if it's a leap year or not. So if you have 29 days in February or only 28, you can check the code at my GitHub. I have an article on the parameterized tests that you can check on my blog. And you also have the GTest user guide if you want to have a look at that. And well, if you happen to see it like live or on YouTube, then you can use these QR codes. So let's start with some examples for some repetitive tests. Here we have 4 different tests, which, well, I say they are 4 different tests, but after all, they are pretty much the same. We instantiate a leap year calendar object, and then what do? We check that, well, here basically like odd years are not leap years. That's probably the easiest example with leap years, just to pass in odd years. And you see that basically we repeated the code. There is one thing that, well, there are actually 2 things changing. One is the year number, and the other is the test name. So we can say that this is pretty verbose, and that's, let's say, a disadvantage here. We repeat the code all the time, and On the other hand, it's quite descriptive because normally you add a test name that is descriptive, and you have a look at this and you see what's going on. So if you have an error because you break the implementation, you will get helpful error messages. So let me show you one. Here, I changed the implementation a bit so that if you pass 1989, then you receive true instead of false. And you can see exactly which test case failed with what input. So even if your test name is not giving you so much information, you will see your input, where it failed, what's the expected and the actual value. So you get a really detailed error message that you can easily work with. Now we can try to limit the repetition with a so-called fixture in GTest. I think this exists in other popular test frameworks as well. So in GTest, you inherit from this testing test class, and whatever you want to share among the test cases, well, you can declare as protected. You can have variables, you can have methods that you can share. So in this case, well, it's still pretty simple. We just share this leap year calendar because it doesn't need any particular setup. So we can move it to a common place. And then you see, basically, we cut each test case into half. Well, I removed half of the test cases as well so that we fit more to the screen. So otherwise, you still have the same names, you still have the same numbers here, you see. The logic is still repeated. But at least we could factor out some parts. So overall, it's less verbose, while we keep the description. So it's still descriptive, and we get the very same error messages, which are quite helpful. And as they are the same, I don't even bother you with showing that. You can test it if you download the code samples. Now we could also use just a good old for loop, let's say poor man's fixture. So we go back to the normal test case without the fixture. We declare a leap year calendar, and we declare the vector of years. So you see, I used C++20 syntax. We don't have to pass the contain type. It's deduced. And then we have just a range-based for loop, and we try with each odd year that whether it's a leap or not, and we expect that it's not a leap year. So the problem here that this is not very descriptive. Now, probably this example is still pretty straightforward, but this is just a degenerate example. So it can get much more complicated in real life. Yet I see people using for loop, for example, and it's difficult sometimes to understand what goes on. But at least we have no code repetition. That's good. But the error messages, well, they are not so meaningful in this case. So if we have a look, we'll see that, well, of course, we have the line number where it failed. But then the only thing that we can see that, well, we passed in an odd year and it failed. But we have no idea which one of them failed. So that's the problem here. We basically lose the information on the real input. So let's see, what does parameterized testing bring us? It brings less repetitive code, also more meaningful error messages. Well, basically the same error messages that we had originally, almost the same. And then easy execution of the same logic, the very same logic, with several different inputs. But as I said in the beginning, this is not a silver bullet. It won't solve all your issues, but this is a good addition to your toolbox. It can come in handy. It's worth knowing about it in some special, well, not special, but in some specific cases. Now let's see how to write it from scratch, when you don't have an existing fixture. So you have to inherit from this class testing test with param, and you have to pass in the type that you want to parameterize. And like we did before, we can put here some common code. In this case, the leap year calendar, although we will see it doesn't really matter where you put in this case, because we'll have only one test case that we instantiate many times with different values. So we inherit from this test with param t, and then we have to write our test case. So probably you noticed that before the macro we used with GTest was simply test, or with the fixture it was test underscore f, standing for fixture. Here it's test underscore p, where p stands for parameterized. So we share our fixture name, we share also the name of this test case, and then we use this get param to get the value that you want to test with, okay? And then you make your assertion, you do everything as you wanted. But here what matters is that you get the value for a given iteration with this get param. That is part of GTest, of Google test. Then the last thing you have to do is this instantiate test with p macro, where you give the suit name, and then you use the name of this class as a second parameter, and then you write your values. You pass your values, and in this, let's say, in this list. So one thing to mention here, that if you use an older version of GTest, then it's not instantiate test with p, but it's instantiate test case underscore p. So it was before this version 1.10. And if you move to 1.10 from with an already existing parameterized test, you will get some compiler warnings so that you migrate to this test suite p. But that's the name is the only difference from a practical point of view. And let's see what happens when a test case fails. So it will tell us, GTest will tell us which iteration failed with a number, which might not be that useful at the first sight, because you have to look up the code to know which one was the first. But in fact, it will tell you that get param was 1989 in this case. So you get back the input. You get all the relevant details. Even when here, okay, you have this value of leap year is leap year and year. This is not very descriptive here, but if you just go a few lines down there, you have the exact input. So basically, we have the descriptiveness of the error messages of our original example, which I find great. So now let's see what to do if you already have an existing fixture. So here you see we use this testing test. We have our fixture, and we have some tests where we tested 1996 was a leap year, 1600 was a leap year, and now you want to share some code of this fixture with parameterized tests. What can you do then? Well, one option is that you just rewrite everything from scratch, like we saw, or you can actually inherit from this leap year text fixture. So I removed the test cases just to save some space, and then we see that, we declare a new class, this leap year parameterized test based on fixture, and we inherit from two classes. One is leap year test fixture to be parameterized. The previous one, I shortened my code a bit and forgot to update this name here. So here you would inherit from this leap year test fixture, what you have on the top. And then the second class to inherit from is this testing with param interface. So before it was testing with param, now we inherit from with param interface, where we pass the type to be parameterized. So why do we do that? We do that because testing with param inherits from testing test, and our fixture also inherits from testing test. So if we would inherit from test with param, then we would inherit basically twice from the same class, and we would have a compilation failure saying that this is actually an ambiguous base. Testing test is an ambiguous base. Therefore, we should go with testing with param interface T. Then we do the same things as we declare our fixture as we used to do before. Now, can we test multiple parameters? Luckily, we can, but it's not something that GTest gives you, let's say, with its own features. You can use, let's say, your own imagination, or you can use whatever type you want. So you could create a class which, you could create a struct that holds all the different variables, all the different parameters you need. But by convention, I would say, we use std tuple. We use tuple to pass in just any combination of parameters. So what you do is that to test with param, you pass in a tuple, let's say, of an integer and a bool in this case. And then you still use getParam to get the right value, but use studGet with the right index to get actually the right value out of the param. So, So here what you can see is that at 0 position, we get the year, and in position 1, we get the expected value. So we stopped using assert false. Now we say assert equal, and we pass in the expected, which might be true or false, depending on the year you want to pass in. And you also pass the year to isLeap. So from here, what you can also see is that you can call getParam multiple times. You don't lose the value there. And from C++ 17, you can use structure and bindings to simplify a bit the code and get, like in this case, all the different parameters at the same time, which is a nice simplification. And then you have to pass in the values. So it's probably that what you would expect. You have to declare your tuples your tuples in testing values. So what goes on here is that we can pass in many different things. We can pass in really whatever you want. But the more parameters you pass in, the less descriptive your test becomes, and the less descriptive your error messages will become. Because you still get the values. Like you can see here that get param returned the tuple of 1989 and false. You see what was the expected value and what was the actual value. So you get still all the inputs, but of course your test name will become probably less meaningful because well, you have to generalize it a bit because you are passing in multiple parameters, and if you pass in your expectation, you pass in the expected result, then you have to generalize the test name. So here, what we have is checks if leap year, instead of saying that okay, this should not be a leap year. So this option is still useful, I think, because there are cases when you just need multiple inputs for your code under test. But if you want to parameterize also like your expectation, then think twice, because maybe you lose the maintainability of your test. That's something to think about. So what if you want to test different types? That's also possible. And we don't have to use any specific feature of GTest for that, because basically that's something we can emulate with a combination of a variant and a visitor. So let's say now we leave behind our leap year kata, and we just have a template function for adding up two numbers. And we want to test it. We want to test that it works with different numeric types. So what we can do here is that as a parameter, we pass in a variant, let's say of an int and a double. And in our test case, we use a visitor. We use a visitor, we define what we want to do. We want to assert in this case that, well, whatever will be passed in, if we add up like 5 with 5 or 5.0 with 5.0, we get 10. Now I know that this is probably not the most usable example, but I wanted to keep it short. And from here, I think we can expand our test cases to see how this can be useful. Because in fact, we could even have tuples within this variant, and we could pass in like 3 values as well, like what two numbers we want to add up and what is the expected result, which might make sense in this case. So to the visitor, we pass the logic we want to test with this lambda in the beginning, and then we pass in get param, and it will take care of calling the lambda with the right parameter or with the right parameters. So here we saw that we could emulate like this type-ish parameterized test simply with a variant and with a visitor. So yeah. But you also have built-in support for these type tests. You can use something that is called the typed test suite. And I found that for this type parameterized test, you have to write quite some boilerplate. So we inherit from testing test, and then we have to register our class with this typed test suite _p. Then we have to write our test case, this typed test _p, where we pass in this type parameter, and so basically the template argument for add, and we pass in this case some fixed values, and we also fix that we expect 11. And now we still have to register the type test suite p macro, and it's still not the end of it, because we haven't added the different types that we want to test. So then we have to create these areas for types where we pass in like an integer, long, size t, whatever types you want to test, and then you call the instantiation of the type test suite. And we must do this aliasing outside, because otherwise the macro cannot deal with these commas within testing types. So that's how you can do this. Now it's possible to combine parameterized tests with the type parameterized tests, which would probably make sense here, because like using these fixed values in some cases doesn't really make sense, but it adds way more boilerplate. I personally find that that approximation with a variant and the visitor works better. But at least this is a possibility. So there are some other frameworks out there. I'm not here to convince you that you should use GTest anyway. Often it's decided by company policies. So with Catch2, you get some generators that you can use as parameterized tests. You can also use doc test or boost test to achieve pretty much the same results. It's completely possible. So time to conclude. Use parameterized test to decrease code duplication. It comes in really handy when you have these cases, as we saw. And you can test the same logic extensively with many different inputs without any overhead, basically. But I would still advise you not to overuse it, because with multiple parameters you can decrease the readability of your test. So use it wisely. And thanks a lot for your attention. I'm checking if there is any questions. Yeah, from Passy, there is one. In the for loop, the error only said something like problem with odd year and not the exact value. But what about if you, in the for loop, use so let me go back. It was quite in the beginning. Here. So what do you mean? Do you mean that I move the vector values here instead of the odd years? Because yes, well, it would be still the same case, because if you have a look at the error messages, you don't see odd years at all. You don't see anything about the vector. We only see that one element, the odd year. So it wouldn't help in this case.